All right, here we go. All right, which row did, on these 3x3s, you have to pick a row or a column. So which one did we decide yesterday? Row 1, the 2, -1, 3. Okay, so there's a signs. You guys remember these pluses? You have to assign a sign value to each one of these, and these just alternate. So someone asked me yesterday, am I going to give you these? No, because they just alternate, starting with the positive, okay? So don't think of it so much as positive, negative. Think of it as stay the same, change, stay the same. Does that make sense? So on this first row, these are assigned, these signs are attached to them. So 2 stays the same, and it's going to be multiplied by a 2x2 minor. The -1 changes. So if I say change the -1, what are we changing it to? +1. 1 times a 2x2 minor, and then the 3 stays the same. So that's going to stay a positive, and that's going to be times a 2x2 minor. So now the 2x2 minors, starting with 2. If you take the 2 and you cross off the row that it's in like this, and the column that it's in, you're left with 4 numbers. Do you guys see them? 5, -2, 1, and 4. That's called the 2x2 minor that's attached or assigned to the 2. So you're going to write those right here. 5, -2, 1, and 4. Questions? Now the 1, if you cross off the column so now we're on 1, this -1 here, but it's really 1 because we changed it. Cross off the column that it's in and the row that it's in. So what numbers are left? The 4, 6, and the -2, 4. Are you guys with me? And on the 3, if you cross off the column that it's in and the row that it's in, you're left with 4, 5, 6, and 1. Now, if you want to double check this, what I always do is I like to make sure that I have a column of 5 and 1 twice. I have a column of -2 and 4 twice, and I have a column of 4 and 6 twice. They should all be there twice if you did it right. And now the rest of this is just how do you find the value of a 2x2 determinant? You cross multiply, so what's 5 times 4? 20 minus this. So that becomes 2 negatives make a positive, so it's 2 times 22 or 44. So the first one has a value of 44. You're going to add that to the next one. So the next one is cross multiply, starting with the 4s. 16 minus -12. What is that going to give you? What's 2 negatives make? So that's going to be 28 times 1, or 28. And the last one is 3 times 4 minus 30, which is 3 times -26, or what? -78. Now add those 3 numbers at the bottom. And what do you get? So for those people that weren't here, I'm going to show you one time how to do this on the calculator. So that's a -6 answer for your determinant. So what you're going to do is on your calculator, press, get this right. You're going to press second matrix, which is the x -1 key right here. And then you're going to, that did not work. And then you're going to go over to edit. And you're going to press, guys, by the way, did I show you guys this yesterday? When you go to edit, how many people have matrices in here right now? Who has a bunch of matrices? Did I show you how to delete these? I'm going to show you right now. If you don't want to, how many people hate typing over the old ones? Does that bother you? It bothers me too. So I'm going to show you how to delete these. I want everyone to press second plus. Second plus. Now, when you press second plus, this is how you clean up your memory on your calculator. So if your calculator is running slow, it means you have too many things stored in it. If you don't need them, if they're just a bunch of stupid stuff, like you could clear all your lists right now. You could, we're going to go to number 2. We're going to go to memory management delete. Press 2. And then you can go to your list right now and clear them out, your matrices, your Y's. So if you have a bunch of equations in your Y's, all that kind of, your programs, you can clean up some of your programs right now. But we're going to go down to matrix number 5. Now I only have 1 stored. So you guys, I'm going to press delete. Delete's right here at the top. right next to mode, right next to the left arrow. Press delete as many times as you need to delete those matrices. You can delete until there's... Now what this does is it frees up some RAM and some memory on your, instead of just keeping a bunch of stuff stored on there. It cleans it up, just like your phones, right? Kind of get out of some of your browsers and stuff like that, so it's not running all day long. Same thing. All right, do you guys understand that? So second plus 2, 5. Delete. So second plus 25, delete. So let's go back to matrices. We're going over to edit. We're putting in a 3 by 3. So at the top, we're going to put 3, enter, 3, enter. And it sets up a 3 by 3 matrix, and you're just going to put your numbers in. 2, enter, -1, enter, 3, enter, 4, enter, 5, enter, -2, enter, 6, enter, 1, and 4. After you do that, press second delete, or second mode, and press second matrix. Go over to math. And right there, number 1 says DET, that's determinant or value. Press 1. Press second matrix again. Press 1 again. So it'll say determinant of matrix A. And your answer is -6. Do you guys understand that? Easy or hard? What's the temperature out there today? Is it hotter than yesterday? It's been kind of chilly, I think. I don't want a jacket anymore. All right, guys. That's so what did we just learn? Determinants. What did we do yesterday? Added, subtracted, and multiplied determinants, and now inverses. Okay? An inverse. What is the inverse of 2? Anyone know? What's the multiplicative inverse of 2? That's the additive inverse. 1/2. 2 times 1/2 is 1. A multiplicative inverse means if you take something and you multiply it by its inverse, you should get 1. So what's the inverse of 1/5? 5. What's the inverse of 2/3? 3/2. Okay, everyone knows what inverse means? Now, in a matrix, what you're going to do is first you have to find the determinant because we need it to be a single number, right? So you're going to do your cross multiplying. You're going to find your determinant. If it's 0, someone tell me, what is the inverse of 0? What's 1/0? Undefined. There is no inverse for 0. So if your determinant is 0, there is no matrix inverse for that. So if you get a determinant or a value of 0 for your 2 by 2, you don't have to do any work for the inverse. You're done. You just have to say no inverse exists. Okay? So if it's not 0, then you have to do this. So if you get a 2 by 2, you would cross multiply, do AD minus BC. Now that's going to be a single number, right? All right, I'm locking the door. I'm locking the door. Supposedly some kid was saying threatening stuff last night at the, what's that Christian group? What's it called?
Young Life.
Young Life.
God.
What?
What were they saying?
Oh, ask Celeste Pierce. Okay. Anyway. All right, so the third step, guys. The third step is after you find your determinant, you're going to take the reciprocal of that. So if your determinant, like the one we just did, was -6, you would write 1/6. If the determinant is 5, you would write 1/5. That's what goes right here. Now mine says 1/AD minus BC, so that looks kind of weird, but it's 1 over whatever you get. Does that make sense? Inverse wise. Then you're going to take the 2 by 2 that you have, and you have to switch some things up. The first thing you're going to do is switch places with A and D. And you're going to write it DA. Do you guys see that? Switch places with this row. Or this diagonal, you switch places. Now, when you cross multiply, does it matter which one's where? Does it matter? If D's up there or A's in the bottom, does it matter when you cross multiply? No, you'll still get the same determinant. Now, on the other diagonal, we're going to keep them in the same place, but you're going to change them to their opposites. So whatever B and C are, these are staying put, but you're going to change them to their opposites. And if you cross multiply that, you're going to get the same answer. It won't matter. So your determinants, the value is not going to change, but in order to get the inverse, you have to do this. And then your last step is you're going to distribute that inverse to each one of these, and you're going to get your answer. The value of the determinant doesn't change, but to get the inverse to work. So the inverse is actually going to be another 2 by 2 matrix. The inverse is going to be another 2 by 2 matrix. And what you're going to have is when you take your original 2 by 2 with your inverse and you multiply them, you're going to get diagonal ones. Because the number of times its inverse is ones, you're going to get a 2 by 2 matrix that has diagonal ones with zeros in the other spot. I'll show you all this. Ready? We're going to do all this fun stuff. All right, so here's your first matrix. You guys see it? Example 8a. So right now, in order to find the inverse, we have to see if one exists. So you're going to first find the determinant. Find the DET. So we're going to cross multiply. What's 2 times negative 4? What's 3 times negative 5? You're going to get 7. It's Thursday, Fret Thursday. So you guys know that? There's always Fret Thursday. All right. Am I doing my work right? Is anyone double checking my work? Is it all right? So did you guys get 7? You guys get 7 for the determinant? All right. Are we done? No, we have to find the inverse now. Does the inverse exist? Yes, because it's not 0. So step 2, it's time to find the inverse. So you're going to take this determinant 1/7 and you're going to take the reciprocal of that, 1/7. You're going to take the reciprocal of it or the inverse of it. You're going to multiply it by the original determinant but switched. I mean the original matrix but switched. First, the first diagonal, we're switching places. This one right here, 2 and negative 4, you're going to switch places. This first diagonal. Do you guys understand that? The other diagonal, you're going to change signs. So it was a 3, now it's going to be a negative 3, and the negative 5 is now going to be a positive 5. So the first diagonal, you switch places. The second diagonal, you switch signs. And then you just distribute this. So your answer would be negative 4/7, negative 3/7, we're distributing right now, 5/7, and 2/7. That's your answer. This is your inverse. If you would multiply the original one with this using our multiplication rules from yesterday, you would get diagonal ones with zeros in the other spot. But we're going to do this with the calculator to show you this. Are you guys ready? So let's go ahead. My battery's low, but that's okay. We will go through this. Oops, it just died. Let's try this calculator. Let's go to second plus, you guys, go to second plus 2, 5, delete that last one. And then second matrix, edit. Here we go. We are going to store our first matrix in A. We're going to call it a 2 by 2. And we're going to put in our original one, 2, 3, negative 5, and negative 4. Okay, you guys see that? You guys have it in there? Everyone got it stored? All right, I want you to press second mode. Clear your screen. Now this time, inverse. This is kind of fun. Are you ready? You're going to press second matrix 1. There's A. The inverse key is actually not in the matrix keys. It's actually on your calculator. It is right here. It's right under math. It's the same key we've been using, but instead of using second to that, we actually want the key x negative 1. So we're not pressing second that key. We're actually pressing x negative 1 because x negative 1 is the inverse key. Do you guys see that? Does yours look like that? Now press enter and you get these ugly answers. Do not give me these answers. How are we going to change all these? Math. Enter. Enter. Boom. All four at once. There's your answer. Who wants me to go through that again? Take time to ask a neighbor to get you there. You guys all get it? Now, remember what I said before? If you took the original one times the inverse, you should get diagonal ones. Watch. I'm going to clear all this out. I'm going to do second matrix 1. There's A. Times second matrix 1 inverse. So I'm multiplying matrix A by matrix A's inverse. Are you guys ready for this fun stuff? A number times its inverse should equal 1. A matrix times its inverse will equal diagonal ones. Diagonal ones, 1, 1, and the other two spots will be zeros. If you would multiply those by hand, you would get 1, 0, 0, 1. Every time. Austin, if you look at the clock again, I'm going to make you do 10 push-ups. That's what my boot camp instructor used to make us do. She said, if one more person looks at the clock, you're going to do another 50 push-ups. Because during boot camp, I used to look at the clock all the time, like, when is this over? This is killing me. I used to go to boot camp at 5 in the morning to do, like, the killer workout. So, and she said, if one more person looks at the clock, you're going to do 50 more push-ups. I'm like, so I had to just like, can you just take the clock down?
Wait, so like when you were
You look at the clock when you want something to end quickly.
No, I get that. But like, were you like boot camp? Were you working here?
Yeah.
And you got to go 5?
Yes.
On purpose?
Yes.
What's wrong?
All right. Let's do the next one. All right. Ready, guys? What's 3 times 4? What's 6 times 2?
0. Or 0.
Is there an inverse? No inverse. Woo! Did you guys like that example? So if you tried to punch that in and did the inverse, it would say error, domain error. All right. Is that so? That's it for that. Now, last thing, guys. The last thing that matrices do to make your life easier is solving systems of equations. So look at number 7. Do you remember how to do these? You did these probably on Alex at least once, right? You have to do elimination. You have to get them to be opposite so you can eliminate them, or you can substitute something in. Remember all that? We don't have to do any of that. We're going to set these up as a matrix. Now, when you set these up as a matrix, you're going to go 4, -1, -3. I'm going to use coefficients only. There's something called reduced row echelon form. Echelon form is when you only use numbers and no variables or equal signs. But you have to keep, in order to do this, everything must be lined up. Your x's must be underneath each other, your y's must be lined up, and your equal signs must be lined up. And then what's my second row?
5, 2, 1.
Now, I want you guys to enter this as a 2 by 3 matrix. Does everyone know why this is a 2 by 3 matrix? 2 rows, 3 columns. So if you want to clear out what's in there right now, press second +2, 5, delete. Second matrix, edit, 2 by 3. This is what it's all for to me. You guys will have to solve equations in every math class you're in. You can do matrices to solve every system of equations for the rest of your life if you can remember this. No, there is a way to do it with inverses, but we're not wanting to do it with inverses. We're doing it the easy way. Now, something that you would use something like this for is when you guys have different investments someday when you're working, and you put some money here, and you put some money here, and you put some money here, and then it'll see, like the stock that you're invested in will say, this one made 7%, this one made 12%, this one lost 5%. You put those in there, and you can do this for every week or every day, and at the end of the month, it'll tell you how much you make by using something like this. They are all done with matrices. All your stocks and stuff done with matrices. All right, I'm going to quit my screen. Second matrix. Go over to math. Go down to the key that says R, R, E, F. Question. Oh, yeah, we already learned how to solve by hand in algebra. I'm not teaching you the algebra way. You guys should know how to solve a system of equations, but I can tell you how to do it. All right, go down to R, R, E, F. Don't go to the ref. We don't want a little guy with the black and white shirt coming out. We want the RREF. It's called reduced row echelon form. Reduced row echelon form. Numbers only. Press it. Then do second matrix A, or number 1. Your answers. Oh. These are my answers? Okay, these are my answers. Press math, enter, enter. I made these numbers up. That's why they're ugly. So your answers are not 1 and 0 and 0 and 1. Do you see those first 4? Those are your identity ones that we just did. Those are supposed to happen. If it solves it correctly, there should be a 1, 0 here and a 0, 1. The answer is the last column. So your x is negative 5/13 and your y is, whatever that says, 19/13. So your answers are negative 5/13 and 19/13. That's your x and your y. So if you would graph these on a graph, that's where they would intersect.
I didn't get that. I got 1, 0.
Did you guys get something different?
Yeah. No, I got that.
Go back and see if you put your numbers in right. You don't have to give it anyone else your calculator. Just go back and see if you entered your numbers in right. Go to edit and see how you typed your numbers in. All right, listen, really quick. Tanner, I'm going to do this really quick for you. Here it is, by hand. I would eliminate the y's because I can easily change this right here to a -2 by multiplying it by 2. Yeah, but you should know how to do this. All right, I multiplied the first equation by 2, and it's right here. You guys see that? And then you add straight down. 13x cancel equals -5. X is negative 5/13. Then you would have to plug that in right here. You would have to plug that into x to solve for y. So this would be negative 25/13 plus 2y equals 1. Add this to the other side. 2y equals, I'm going to change 1 to 13/13 and make that, what was my answer? I don't feel like I'm getting my answer here.
3.
Was that the answer? Oh, because I have to divide by 2. And that would make that 38/26, which makes that 19/13.
Wait, can you go up to the top?
Okay, I just made these numbers up. That's why they're so ugly. We don't usually get fractions like this. But do you guys remember doing it like that?
Can you go, Ms. Collins, can you go up to the first part of what you started?
You have to eliminate a variable. It's called elimination. So the original problem, if you look at the original problem, it looked like you had a -y and a 2y. So if I can make that a -2, the y's would cancel. So if I need to make that a 2, I need to change the whole equation by 2. You double the whole equation. And you make it this. 8x minus 2y equals -6. And then get rid of that one and then add straight down. And solve for x. And then you just plug that into the other one. Now, you may not remember this, but there was 3x3s. At least in my class, in algebra class, I made my algebra 1 and algebra 2 do 3x3s. These take up about 2/3 of a piece of paper to solve. And even if I took my smartest kids, even my smartest kids would make like one mistake and miss the whole problem. Usually only about 5 people got them right. But matrices do them for you. So you had these on Alex at 3x3? Yes, James. All right. These could be on your ACT. So if you see these on an ACT, do them with matrices. Do them with matrices. Are you guys ready? We're going to set up -3, 1, 1, 2. Do you guys understand where I got those numbers? That's the first row. Second number is 5, 2, -4, 21. Again, these have to be lined up. What would you put if something was missing? What if the z was missing? You would put a 0 in. 1, -3, -7, -10. So this is a 3x4. Do you guys understand that? So type in a 3x4 matrix. I'm going to first press second plus 2, 5, delete. All right. Second matrix, go to edit, type in 3 by 4 first. -3, 1, 1. You guys, I'm telling you, on your ACT, if you see any kind of system, solve it with matrices. If you put in one wrong number, you will miss it. After you put the numbers in, double check that you have all the numbers in correctly. I always do that. Double check. Take the time to double check that you don't have any wrong numbers. I checked it from the original equations and what I wrote. Okay, I'm satisfied that mine are in right. So I'm going to press second mode and quit the screen. Second matrix, go to math. What am I looking for? Reduced row echelon form, RREF. It's under B. Press enter. Second matrix 1. You're going to get, now, you're going to have 3 rows, 3 ones now diagonally. But your last answer is the last column. So X is 1, Y is 6, and Z is -1. You write it as an ordered triple. You write it as an ordered triple. How do you know if you're right? If you plugged in a 1 into the original equation for X and plugged in a 6 for Y and a -1 for Z, you would get 2. If you plugged in a 1 for X here, a 6 for Y, and a -1 here, you would get 21. Yes.
So would that order always be like X on top? Y
Yes,
on
it goes in order. Well, it depends. Like as long as you have them in order, written, XYZ number, XYZ number, XYZ number. The one, this diagonal 1 right here, when you have a 1 here and a 0, 0 here, it means X has been solved for cleanly. If you have a 0, 1, 0, 1's in the Y spot. And then the 1's in the Z spot on the third column. So that means they're all solved for. Now, if you have any crazy numbers, you might have 2 of the lines might be the same line, or maybe they're parallel lines. So if they're ever parallel or the same, you're going to get weird numbers here. Then you might want to go ahead and like just try to graph them and see what they look like. Okay, then you have the wrong numbers in. Go to second matrix. Huh? You can't get a different answer if you have the right numbers in. I'm checking my paper. This is a 5. That's a 5. That's a 5. So that 3 right there is a 5. Your calculator will not give you a right answer. It's only human error that will give you the wrong answer. Okay? All right. With that said, you might get something like this on an ACT. It might say use an inverse matrix to solve the matrix equation. You do not have to do that. This right here is the same thing as my number 7. It really looks like this. This is what this problem really is. If you do multiplying, that's what it looks like. This is the X, this is the Y, this is the X, this is the Y. These are your constants. If you did your multiplying, you know how you do row 1 times column 1? You would end up with the X's and stuff like that. So if you see like this, to me, this is already set up. I would do a 2 by 3 on the matrix. Do not type in the X and Y. Type in 2, -3, 1, -6, 8, 2, and it'll give you your answer. Do what we did. I don't do it with inverses. I do not teach this with inverses. I just do the RREF key. So just type this in as a 2 by 3 if you ever see something like that, and you'll get your answer. There's some other ones you guys can practice. Do you guys see this word problem number 8? How that's already kind of set up for you? So you might be doing a problem like this. A workout group is doing exercise stations. The table below describes the number of exercises completed by each member. You could solve this. And what would you be solving for? You can figure out how much each point the exercise was actually worth. So they probably give you points per exercise. They're probably not the same points. And you can figure out how many points they were awarding for each exercise by doing that. You would be solving for points for the first column, which was, I can't even read these things, rowing, medicine ball, and jump rope. They're probably different points, but you can figure out how much the personal trainer is assigning each exercise. So you can do that with the 3 by 4. But we're going to do one more problem today, guys. We're doing the bonus. You could have something like the bonus on an ACT test. The reason that an ACT might give you a question like this is because you cannot, you have to have some math skill to do this problem. A calculator will not give you this answer. So they will give you a problem sometimes like this on an ACT. What would you guys do first if this was your problem? Look at the bonus. I heard someone say distribute -2. You are correct. So this first one is -2w minus 10, -2x plus 2z, -6y, and -16. It's still a 2 by 2, but it's been changed a little bit. Then you set this equal to -16, -4, 6, 2x plus 8z. Then what can we do? We're solving for x, y, and z, by the way. Is there any of them that you can solve for pretty easily? I want you guys to circle this one. Circle these two right here. Those are in corresponding positions. They're both in row 2, column 1. I can solve for y right now. What is y? It has to be -1 because you're going to take -6y and set it equal to 6. So y is -1. That's one of your 4 answers. Now you have 3 answers left. So if you see a y anywhere, you would fill that in, but I don't see any other y's. What's another one I can? The W one. Okay, I see it. Do you guys see it? The W one. I'm going to actually make this orange. These are in the same spot. Go ahead and solve for W. This was actually on an ACT test. That's why I put it as a bonus. So W is 3. At this point, you probably already know your answers on an ACT. It's multiple choice. You probably already got to figure out just from these 2. Okay, but that's 2 of your answers. Now, the other ones are X and Z. So what we're going to do is we're going to set this up. -2x plus 2z equals -4. And we're going to line up the second one. 2x plus 8z equals -16. We're going to line it up. X's under X's, Z's under Z's, and numbers under numbers. Now, you can either solve this yourself, or at this point, you can plug this part into the matrix calculator. But I think this one's easier to solve by hand. Someone tell me why this one's easier to solve by hand. X's cancel. They're already opposite. What's 2z plus 8z? 10z equals -20, so what does z equal? -2. There's your third answer. Now, if you know what z is, how can we find x? Plug it into one of these z ones. Pick one. Let's plug it in right here. This last one right here. 2x, and then 8 times -2 would be -16. So you can take 2x minus 16 and set it equal to -16. I think it's going to be 0, isn't it? And x is 0. That's good algebra right there. Do you guys see why that could be on an ACT test? That's a good question for an ACT question. You have to know a little bit about matrices. You have to know a little bit about solving a system, and a little bit about just plain algebra, corresponding positions. All right, that was a lot. Sorry for the long